Can you guys hear? See the screen?
Yeah, good morning, sir.
Can you see the screen?
Yes, sir.
Yes, sir.
Okay, so today I just want to give you guys an assignment, right? So this assignment is pretty simple. Just find two problems that you do maybe from UG, or if you work, two problems that you face in your engineering life, and just write some small programs using Matlab to solve them, right? You guys think you can do that?
No, sir.
No?
Yes, sir.
Yeah, because it's pretty simple. Just two script files, two problems. Don't do the projectiles one, just don't do backup projectiles question, right? You can do it if you're looking at different things than the example we looked at in class, right? But try to find two questions, right, that you do maybe in some other course or something, and write a program for it, right? That's all. It's pretty it. I'll send this little outline here that really tells you everything that you need to know, right? What to comment in and how you're gonna get your marks, all right? And the due date is the 7th of May. So the 7th of next month. I think that's about 2 weeks from now. Yeah, 2 weeks from now. All right. Good. So I'll send this to you guys by email after class. Good. So as promised, what I have scheduled for this class is a little bit of nodal analysis using Matlab. Now, you guys did your electrical fundamentals course and you did nodal analysis, right? So this should be familiar for you guys. Let's go through. So we know from the electrical fundamentals class, right, that essentially what we do, we generate equations of admittance and voltages equaling to different currents, and we generate usually 3 or 4 of them, and then we treat them as simultaneous equations, and maybe we can use matrices to solve them, or we use the substitution method or something like that to solve these simultaneous equations. So let's look at an actual circuit. Let's take this circuit, for example. Let me get my pen. We have this circuit here. We got 2 current sources. We're going to do nodal analysis, right? Nodal analysis. And it's fine if you guys don't remember all the nodal analysis from electrical fundamentals class, right? But this is just to show you how Matlab can be used for an electrical engineer, right? So what we usually do is we set up a reference point here, which is the ground here, and we set up our node. So V1, V2, and V3, right? Then what we do, we use KCL, Kirchhoff's current law, that says that the sum of voltages flowing into a node, so something like this, okay? This is I1, right? This is I2, and this is I3. KCL says that the sum of voltages flowing into a node is equal to 0. So I3 plus I2 plus I1 should be equal to 0. And we apply that concept for each of the nodes, generating simultaneous equations that allows us to solve for the voltages V1, V2, and V3, because we don't know them, right? So let's do that. So just clean up a little bit. So for this first part, node 1, V1, this node right here. We know flowing in is 5 amps. Let's say that voltages flowing in are negative so that it works out nice when we try and set up our simultaneous equations, because a negative sign, let's say we put I2 plus I3 minus negative 5 is equal to 0. We can, yeah, right? We can set it up so that not I, this is V. V. Right? We can set it up so that when we carry over this -5, right? When we carry over this -5, it's something like this. Just 5 is equal to, and you got some expressions here, right? So setting the current going in as being negative will help us out a little bit. Right? And then we start generating equations, right? We generate equations like V1 minus V2, right? Divided by 10. So V is equal to IR. So I must be equal to V over R. And this here is essentially 1 upon R. 1 upon R is what we call the admittance, right? Why? You guys know this from the fundamentals, right? So V upon R is essentially the admittance times the voltage, which is all your nodal analysis theory. Right, so we get that. Plus, so that's here. Well, this will actually be flowing out. So this one is going in, and this here is going out, and this here is going out. And we just make assumptions on that due to inspection of the circuit, right? And then this other part, 20 ohms here. So 20 plus V1 minus V3, which is on this side here, right? V3 minus 5, which is -5 going in, and these are flowing out, is equal to 0, right? So that's the first equation, which is here. And of course, we simplify that equation, right? We got something like here. Let's just pull it out here. V1 upon 10 minus V2 upon 10 plus V1 upon 20 minus V3 upon 20. So dividing something by 20 is actually minus 0.05 of that thing, right? Because 20 is kind of like just dividing it by 10 and dividing it by 2. So like something divided by 10, like V1, is 0.1 V1, right? And dividing it by 20 is like dividing that by 2 again. So it's 0.05, right? And so that there is V12. This here is V3. This here is minus 0.1 V2. And we get this equation here, right? And of course, the -5 there. Let me zoom in some more. The -5 from that part of the equation. Remember, we did it that way so that when we carry it over, we can just be 5 is equal to this stuff here. So we set up the first equation. Then, of course, we need to do that for the second and third nodes, right? That's the first equation. Now the second node. Do some erasing again. This node here. We got 3 of them again, right? So one is V2 minus V1 over 10 plus V2 minus V3 over 40. And this again is because current's coming from here, right? Current's coming from here. So these are flowing inwards, right? So we make that negative. Essentially, it would be minus V1, V1 minus V2 divided by 10, but multiplying by -1 essentially makes it V2 minus V1 over 10, right? That's why we have this little switch here. And we continue on with minus V2 upon 50, right? And that's our second equation. And all of that is, of course, equal to 0. So we have second equation for node 2, right? V2 upon 50, V2 minus V1 upon 10, V2 minus V3 over 40. Do the same simplification thing again, and then we just get values for V1, V2, and V3. And then we go and do the same thing for this third node, right? We do -2 for this third node. Let me erase that first. So it's flowing in, right? So we do -2. And then we do V3 minus V2 over 40. And then V3 minus V1 over 20. And we set it up, right? So after we get these three equations, generally we would go about putting them in the matrix, find the inverse of this matrix, right? And then solving it, or we take the three simultaneous equations, right? This equation here, and the one from before, this one here, and we'd solve them using some method that we learned in mathematics, right? In your EMT class. But since we have Matlab, what we can do is take those three equations, put them in a matrix, and then just use Matlab to solve. So if we add these three matrices, how would we go about finding the unknowns? How would we find V1, V2, and V3? Well, essentially, what we do on paper is find the inverse of this matrix and multiply that by both sides. So essentially, we get something like V1, V2, V3 is equal to 502 times the inverse. Let's just call this Y. Let's call this matrix Y times the inverse of this Y matrix, right? And on this side, it would be that Y matrix times the inverse of that Y matrix, which would just be the identity matrix, right? Which would just be like multiplying by 1. When you multiply the inverse of a matrix by itself, that is just equal to the identity matrix, right? Or 1. So we do that and we find the values. So now for me, since you guys know how to create matrices in Matlab, right? We did that. I want you to do this in Matlab. So open up Matlab or Octave, put these values in, right? So make a variable. We call that variable Y is equal to square bracket, these values, and then of course, semicolon to make a new row, right? And then you'd put the next ones, and then semicolon to make a new row, and then you put the next ones, right? And call that Y. And then we remember the function that introduced briefly in one of the other class, INV, right? INVY, and that will give you the inverse of Y, right? That will give you Y inverse. And then we can multiply that by this matrix here, right? So we can call this matrix I, and we say I is equal to 5 semicolon 0 semicolon 2, right? Remember, because it's a column matrix and not a row matrix, right? It's a column matrix. So that's why we put the semicolons like this, and we can multiply that. We can do like inverse Y times I, and it'll give you the answers for V1, V2, and V3. Because the matrices work out, and what this is going to output is a column matrix as well, right? It's a column matrix, and we'll have the answers, the values stored inside. So give it a try, and let me know whether or not you guys need help, right? And let me know what answers you get. Right, so just put these values in the matrix and get calculating. If you need help, you can share your screen and I can help you out. These are the values here.
Sorry, doing it just like how you have it on the screen, right?
Yeah. So this here are the equations we found, right? And we want to solve these equations using Matlab. So plug these into your matrices, right? And solve them. The function that you need to remember is I and B, Y, right? If whatever your variable name is, if you name your variable here, Y, then this matrix here, Y, then you can find inverse of that matrix using this function. Okay? Make sense?
Yes, sir.
Start working. It shouldn't take long. 5 minutes tops. All right. Anyone got any answers for me?
I got something here.
Mm-hmm. What answers you got?
V1 is 404.29. V2
Okay.
350.00.
It is.
V3, I don't. V3 is 412.86.
Okay, good. Yeah, that's all right. V1, V2.
Okay.
Okay, did anyone not get these answers? So everyone got these, right? All right, let me just briefly run over the code again. And as always,
in y inverse times x, right? Which is
well, whatever you name the variable as, right? If you name whatever you name the variables as, right? Y
so
is
just
the
type inverse y
INV open bracket Y.
dy.
I'll
and
show
then
you. I'll show
I.
you. I'll show you. Let me open up Octave. Right, and in Matlab is the same thing. Try and use Matlab more next class. Where is this? Where am I? Okay. Question. Okay. Yeah. So we first do it's pretty simple. Yeah, and you can do this in a script instead of just typing in the command window, right? So you can do it as a script so that it's hard coded and you can save it. All right, good. So first we set up the Y matrix, which we can do like this. Now the reason I didn't put it all in one line is because I want to make it a little bit neater, and you can just press enter and space and tab, and it's not going to affect the code in any way, but it just lines up the variables nice, so it looks like a matrix. All right, so you can do it this way as well. And obviously we put the semicolon in the end because semicolon in the end doesn't display the output. So let me show you guys that. So if I type x equal 4, what it's going to do is going to show up x equal 4 in the next line, right? Y equal 5 is going to show up y equal 5 next line. But if I do y equal 5 semicolon, it's not going to output anything, right? It's just going to suppress the output. So that's why I put the semicolon in the end, right? Then we set up the I matrix. I is equal to 5, 0, 2. And then we do V, which is your voltages matrices, is equal to the inverse of Y times I. So this is it. Very simple. I run this code. Okay. And in my command window, let me just CLC. Let me just run it back. So I run the code and it just outputs V is equal to, and it gives me the matrix. And I could put this answer and write it down. If I was doing a circuit analysis problem or something like that, right? Now, what do you guys think? Is it easier to solve the simultaneous equations by hand, or is it easier to use Matlab? What do you think?
So as long as you know what you're doing in the Matlab, are easy in Matlab.
Exactly, good. So Matlab, you guys are now starting to see that's a really useful tool for engineers. Now, this is easy and you can still do it by hand, right? It might take a bit longer, but you can still do it by hand. Now for this one, imagine if you had a big complicated circuit like this, right? You got V1, V3, V4, you got IX, and you got some dependent voltage. So it's based on IX. So you guys remember from your nodal analysis, you would have to go, you'd have to make some super node here, right? And then you generate 4 equations or something. You'd go, you do your nodal analysis here, your nodal analysis here, you do your nodal analysis, your super node, you generate an equation from your dependent voltage source, and you end up with 4 equations, right? So you do all that, you do your supernode calculations and stuff, and you end up with a 4x4 matrix. Who here can find the inverse of a 4x4 matrix? Can anyone? Can you remember this? Right? It's very hard. It's very hard. But with Matlab, we can just input that matrix and then do the same thing we've been doing. V equal the inverse of y times I, and we get the answers, right? We get the answers. So try for this 4x4 matrix now, right?
Finish, sir.
Okay, great. Is everyone else finished as well?
No, sir.
So let me know what answers you get, right? Of course, I took this from a textbook. The answers are here already, right? So here.
So I got 18.111, 17.918, negative 22.639, and 10.000.
Okay, good. Right. So for this example, at least, is definitely easier with Matlab, right? Because even if you were to try doing this by hand, right? Because there's so many numbers, the possibility of you making a simple arithmetic mistake or messing up a minus sign is highly probable, right? But with Matlab, what you do is you just double check your matrix, right, before you enter it. Double check your values, really good, maybe check it over once or twice. And then you press enter and your code is good, right? So as you become more proficient with Matlab, Matlab is probably going to be a first choice for complex circuits like these, right? So for homework, maybe you can go to your electrical fundamentals textbook or something like that and find the hardest circuit analysis problem you have and get the equations, of course, and then use Matlab to solve and make sure you get the right answers, right? So you can do that for homework. The
Excuse me,
super
sir.
yeah, good. Go ahead.
In this second equation, you say we're gonna use the Fourier analysis formula, but we haven't been taught that.
The analysis formula for this.
Yeah, the Fourier analysis.
Fourier analysis.
Between V2 and V3, yes.
Okay, no, super node. This here, are you an electrical engineer or a mechanical engineer?
Pardon?
Are you an electrical engineer or a mechanical engineer?
Electrical.
Okay, so you guys learned about nodal analysis, right?
Yes, we did.
Okay, good. And you learned about super nodes, right? Super nodes. Yes or no?
Not yet.
Okay, good. But this example here is easy, right?
Yeah, that's easy, understandable.
This one, you know this one, right? This one's
Right.
good.
That's good.
So, okay, so I need to explain maybe what a supernode is so you guys can understand this a little bit better. Okay,
Right.
so because here, right, we can't accurately describe the current flowing through here because one, all we know is a voltage, right? A voltage here, and there is no resistance. So we can't accurately describe how the voltage is flowing through here. And if we try and write equations, they're not gonna encompass all the variables to be able to be solved simultaneously. And that's one of the requirements for simultaneous equations is that we have a number of equations that equal to the number of unknown variables, and they all operate simultaneously, right? And rely on each other, essentially. But when we have dependent voltage sources like these, it doesn't work out like that. So other, electrical engineers and scientists from before, they developed the concept of a supernode. Okay, how does that work? Well, essentially what we do is we generate an equation for the current flowing through here, right? How we do that? We say V2 minus V3 is equal to 10Ix, right? And that's going to be our equation for node 2, right? 10Ix. From inspection, what is Ix, right? What is Ix? Well, Ix is the current flowing out of this node here at V1. So of course, we're going to generate our node 1 equation, which is minus 5A, 20 ohms, right? So that's this, right? Minus 5, 20 V1, V1 minus V2, 5, V1 minus V4 over 2. Right? And that's that 2 ohms here. So the Ix here is this V1 minus V4 over 2. What we do V2 minus V3 is equal to 10Ix. We sub in what Ix is. And remember we said Ix is V1 minus V4 over 2. So we put that in, right? Ix, so 10 times this is 10 V1 minus V4 over 2. And then we do some simplification, of course, right? 5 V1, 10 divided by 2 is equal to 5. So 5 V1. So let's write this back. V2 minus V3 is equal to 5 V1 minus 5 V4 And then making that equal to 0, we get minus 5v1 plus v2 minus v3 minus v3 minus 5 going over plus 5v4. And we get our second equation here. Right? Good. Now, for a third equation, remember we would do node 1 equations, node 2 equations, node 3 equations, and node 4. What we do is we use the node 2 equation, we replace that with this. We replace that with the dependent voltage source equation. And we replace the equation for node 3 with the supernode equation, which is essentially supernode equation, which is essentially the equations for node 2 plus node 3. How we do that? So that's this equation that we're going to generate here. But let me show you how we do that. What we do is we create a supernode. So a supernode is essentially just drawing like a little blob in the circuit and hooking two things up and pretending that that's just some point. So we replace this thing here with just like a dot. And we say the currents flowing into this, right, and out of this are currents flowing into and out of the supernode. We just generate equations based on that, right? So we can do things like here, we know V3 over 10, right? Here, we know V2 over 4, right? Here, we know V2 minus V1 over 5. Here, we know V3 minus V4 over 15, right? 15. And then we know that the sum of that is supposed to be equal to 0. Of course, we take directions into consideration, right? So these here are going to be negatives, and this here is going to reverse out. Instead of being V1 minus V2, it's going to be V2 minus V1, right? And we add them up and equate them to 0. So this is what we have here. Add them up and equate them to 0, okay? And then we simplify and we get this, right? And you can already start to see that these are a lot of equations, right? And it's getting complicated. And of course, we do the regular thing for node 4, right? V4 is equal to 10. And that's simply just because we got 10 volts there. All right, good. So then, right, so V4 is equal to 10. This we can abstract a little and say that 0 V1 plus 0 V2 plus 0 V3 plus V4, which is equal to 10. So essentially like 10 being carried over. All right, good. So that's it. We have our matrix here, right? This is our matrix. Now to solve this by hand, it is going to take a lot of time, right? Just to find the inverse of 4x4 matrix. So instead, what we do is use Matlab, chuck those values into a matrix, right? Chuck the other one into a matrix, find the inverse, multiply that by the other one, and then we output the answer into some variable called V, right? Does that make sense? I know it's a lot, and if you don't know the advanced nodal analysis concept, as you continue learning electrical engineering, you'll come across it, right? In circuit analysis course, maybe electrical fundamentals 2, or your electronics course or something like that, right?
Okay, sir.
You'll come across it, right?
Sorry,
But
question.
since you learn in Matlab, you'll be prepared when you do have it. All right, go. The person with the question, go ahead.
Sorry, the thing we explained recently with the circuit, is it similar to superposition?
Mm,
Or is two totally different things?
It's kind of two slightly different things, right? So this is just a way to do nodal analysis, right? Superposition is a bit different. Maybe we can do a superposition example in another class.
Yeah,
Right.
that would be good.
Okay, but this makes sense, right? You would definitely prefer to use Matlab to solve this matrix and solve 4 equations by hand, right? Should be a resounding yes. Okay. So now, of course, you can make this into a program, right? So of course, we got some program here at the top. I just remove this line, right? This program, we do comments, right? This program computes the nodal voltage. And of course, this is a script file, a .m file, right? That you created, some nodal analysis.m, ELE 1214 homework, that electrical fundamentals homework.m, whatever you want to name it, right? You create some script file, you put some comments, this program computes the nodal voltages, right? And this is probably how you would want to do the assignment, right? You say, given the admittance matrix Y and a current vector I, where Y is the admittance matrix and I is the current matrix, right? We can find V using some stuff, and you can write comments describing everything with the problem and your code, right? And then here is just your basic code, setting up the values for Y is equal to, I is equal to, right? So what they did here is the transposition operator, right? You remember the apostrophe? We do I apostrophe and that transposes I. So you can enter I as a row vector and then use the apostrophe, right? To transpose it to a column vector, or you can just do 5 semicolon 0 semicolon 0 semicolon 10, whichever one you feel like it. And then this line is familiar. We do V, some new variable V, which is a voltages variable, is equal to the inverse of Y times I. This makes sense. Now this one here, this line doesn't make sense. Try typing that line out in Matlab. Let's try just typing the function out in Matlab. F print F and put 2 colons. Let's type hello. What does that do? It prints hello, right? Good. Now let's try typing hello and putting \n. What does that type? That types hello, but notice how this little cursor thing here, this little double arrow thing is in the nodal line. What this \n is, so we call it escape sequence. It's essentially like pressing enter on your keyboard. So you know you're in a text document, you're here, right? And you press enter, it goes to the next line, next line, next line. That's essentially what that / does, right? So let's try typing 2 of them, right? \n again, right? You see it creates more space there. \n creates more space, right? And \n again, right? More space, more space, more space. So that's like essentially telling the computer, type this thing out, then leave some space if you want, right? So what this command does in the program, essentially talking back to the user, right? It's saying nodal voltages V1, V2, V3, V4 are, and then it does this command. So this command, we know displays V, and this command writes nodal voltages V1, V2, V3 are. So coming back to the code, so I was working the simpler example. Let me try putting that in, right? Let me try doing F print F, right? Colon, the nodal voltages are, maybe a colon, and then run my code. Okay. Let me see, I'll see. Nodal analysis, right? So you see here, it prints the nodal voltages are semicolon, and then it prints V is equal to something else, which is what it would have printed before. So here we want a space, so we want to neaten it up. So we can put that \n there. Then we can save this, of course. And it'll print it neatly. The nodal voltages are V is equal to that. Okay. So coming back to something complicated again, like the projectile ones, remember they had like a lot of things happening, right? So maybe you can come back with this new function, fprintf, and see if you understand a little bit more of the projectile program, right? Good. So try adding something like this into your script file with your admittance matrix and your I matrix. Maybe something to neaten it up a little bit. The nodal voltages are, you can, of course, the nodal voltages V1, comma, V2, comma, V3 are, right? And you can, make it as nice as you want, right? So try putting that into your program and seeing whether or
Sir.
not it works, right? Yeah, go ahead.
Sir, just a quick question. What the fprintf represents again?
So it's a function that prints out to the command window, essentially, right? So fprintf stands for file print, but it stems from things like C. So in the C programming language, we have printf, which is essentially file print. And then there's the standard input output library that helps us print out to the screen. So essentially, it's just like programming tradition that it's named fprintf. And the computer kind of thinks of the command window as a file. And later, maybe, I don't know if that's within the scope of this course, but you can use printf functions and fprintf functions to print into like text files and stuff like that, right? With different flags that you enter into it, you can print the text files and all sorts of other things, maybe even to Excel file and stuff like that. So it's kind of an all-encompassing printout function, right? Does that make sense? No?
Yes.
It's just a function that prints out to the command window. For now, it can do a lot more, right? But it's a function that does that. It can access different variables so that we can access, like, let's say an element of Y and print that variable out, but we learn more about that as you progress, right? So try using fprintf within your code. Yeah. You guys getting through? Play around with the print statement, the format print.
Sir, are we supposed to do this in script or the normal command window?
It's nice to practice creating script files, right? Because for the assignments, you're gonna create script files, right? So pretend this is a program you're writing, right? So to do your homework.
So can you create that script file and show me how to do it? Yeah, I'm getting some problems with I saving a file name in Octave.
Okay, so remember no spaces, right? In the file name, use underscore. If you want space, maybe that's the problem. If not, share your screen and I'll guide you through it.
I'll try backwards.
Oh. So everyone else is getting along good, right? You understand a little bit about script files, you've been saving them, you've been writing programs and stuff. And the exercises, I think I sent out exercise 1, 2, 3, 4. Let me see. You guys went through them, completed them, didn't have any trouble, right? Yeah. Exercises 1, 2, 3, and 4.
Sir, I did them, but they weren't related to the script files. They were just commands in the
Yeah,
command
yeah.
window.
Just commands. I think, which one? Maybe exercise 1 spoke about script files, did they? Let me see. No. All right, I'll make one about script files. But you guys should know script files. I know. I'll make one about script files and send it. The script files are essentially the same code that you type in Matlab in the command window. That's the same code that you type in a script, right? And you can save the script with all the values inside so that when you close off Matlab, you can get it back, right? And you can save the script so that when you come up with another nodal analysis problem, you can come back in, change all these values really quick, change all the values for I, and then just press run and it'll work, right? You come back in, maybe I change to 4, 6, 1. You change the values up quick and then you run and you get a new answer, right? Same thing with your projectile, not this one, the simpler one, practice.m. You come in here, you change your velocity, you change your theta. You of course use your new T flight. You can write some code to calculate time of flight, right? Maybe if you want for one of your assignments, you can take this code and add in the code to calculate time of flight and use that as one of your assignments, right? Remember, you need to do 2 problems. So yeah, you can just come in here and change the values real quick, velocity and theta, and then run this again, and you solve another projectile question. Same way with nodal analysis, right? You can just plug in your stuff and solve another nodal analysis question. Right?
Sir, that was the projectile script.
Huh?
That was the projectile script you sent us.
Yeah, I just opened the practice one we had.
Sir, I noticed I missed the last class, right? I noticed someone told me you erased a lot of unwanted stuff. Just confirming.
In this, yeah, I just try and make the script as simple as possible so that people could understand it easy line by line, right? try to make it as simple as possible. Because the other one is more complicated, right? Even this one I think is a bit more complicated because this refers to another script file that calculates time of flight. And then you would want to open that one, right? And this one is here as some code calculating time of flight, which you would learn from your mechanics class. You can just as easily take this practice script and add in code to calculate time of flight, right? Okay. Discard. Okay.
Sorry, you're gonna be creating a window on Moodle for we upload the assignment, right? Or we gotta do it by email.
Well, I don't have access to Moodle for this course, so email. You guys know my email, right? Let me type it again in the chat. Neil. Okay. Yeah, and if that one doesn't work, it's just this one. But only use the second one if the first one doesn't work. Yeah. So everyone get through with the format print, file print.
Yes, sir.
Good. All right. So now your life is a bit easier now that you can do circuit analysis with Matlab. Okay, good. You can also do loop analysis because for me personally, I like loop analysis more than nodal analysis. I think nodal analysis kind of stupid sometimes. Loop analysis is easier, right? Because with nodal analysis, you use admittance, which is Y times V. And with loop analysis, use impedance, right? Which is Z times I is equal to V. So for me, this is more logical to think about it as an electrical engineer, right? And essentially just create loops. And you guys know how loop analysis works, right? So you create your three loops, you generate your simultaneous equations, same thing, right? You do I1, I2, I3, right? You guys know your stuff. I1, right? I2 flowing in this way, I3 flowing around this way. And you know, I1 is coming down this way and I2 is going up this way, right? So we gotta do some subtraction there. We're gonna have some interaction there, right? So in your 10 ohm resistor here, your 10 ohms, you're gonna have 10 ohms times, because V is equal to IR, right? The resistance or V is equal to IZ, but V is some sort of a complex variable, right? When you're dealing with impedance. So this here would be, you know, your I1 minus I2, and so on and so forth, developing your loop analysis, your different equations, right? So, and of course, after generating equations, and you see the numbers here, much simpler, 10, 4, 40, and 30, like instead of 0 point whatever. So the numbers are better. That's why I like loop analysis more. And of course, after generating equations, shove them into matrix variables and do your calculations, you know, simple program again. And then Matlab is just going to do all the calculations for you, right? And of course, after calculating different things, right? Let's say we calculated I1, I2, and I3, right? And that's in your variable I. Let's say in this question, they asked specifically for the current flowing through resistor RB. Resistor RB. Which resistor is that? This here, this 5 ohm resistor. So we calculate what I was this. So this here was probably I3 and I2, right? So I2 minus I3. So you can do additional commands saying that create some new variable I or B, right? And we say that's equal to, and of course we can access elements in the array, right? So I is some column matrix, right? With I1, I2, and I3. So we can access elements in them by saying RB is equal to I, and we use our parentheses to say we want to do here the second variable I2. So I open parentheses 2, access that second variable minus the third variable, which is I3. Right? And then it's gonna do this calculation, assign that value to you, right? To this new variable. Or you can of course do a print statement, printf, right? The formatted file print, the current in resistor, whatever, right? Semicolon, do that calculation and we'll output the value, right? And we'll print it out nice and neatly. You can use your \n, right? To make sure it's printed nice and neat. And you get calculations like that. So not only can you solve for the currents, you can solve for what other auxiliary things that they might ask. And they can ask things like power, and you know your equation for power as well, right? FP is equal to IV, and you do calculations from there. Okay, good. So for homework, you can, I'll send this, you can go through the others if you want. As a mechanical engineers, you guys don't really need to worry about this a lot. So, but you can still go through it if you like the electrical fundamentals class, and you can go through all of them, look at how they're solved. And I think this one especially is a pretty big matrix. This is a 5x5 one. So you definitely want to use Matlab for this circuit, right? Instead of, trying to solve that by hand. It's just going to take a long time, right? So to save time, use Matlab. Okay, good. So that's all I have for you guys in this class. So it's a pretty short class, but hopefully everyone created the script. Everyone got the answers, right? And everyone is now able to take on the assignment. So for the assignments, as I said before, you're going to find 2 problems from your other classes, right? Maybe not, if not from university, from work as well, right? You can find 2 problems that you face in the engineering life and write 2 scripts to just solve those problems. So whether it be circuit analysis, whether it be projectiles, velocity displacement, Newton laws, fluid mechanics, your physics class, whatever you want to do, right? Create some script files and solve those problems using Matlab, right? This is going to go for 20 marks. Now, this could be adjusted depending on how many assignments I give throughout the semester. But for now, it's going to go for 20 marks, which is 20% of your 100% that you'll be getting with this class, right? And of course, 75% and above is an A, right? So do with that what you will. All right, good. So I'll email this out. Everyone's getting the emails now, right? Okay, good. So for Chris, right? First, you need to develop an algorithm, right? And then program that algorithm into Matlab. And Matlab will give you the outputs, right? So, I should probably discuss like problem solving a little bit. So I know I've been mentioning this a lot with functions, right? So there's some function, right? Like the sin x function, whatever, and you put some amount of inputs in and you get some amount of outputs out, right? So before you guys go about picking problems for your assignments, like let's say the projectile problem, for example, you want to do this little black box analysis first. You want to say, okay, for the projectile example, I'm going to get 2 things. I'm going to get velocity and I'm going to get an angle, theta, right? And I want to take those 2 things in and I want to output x coordinates and y coordinates, or I want to output time, velocity, At impact, I want to output horizontal components, vertical components, all kinds of things like that, right? So when you're picking your questions, specify what kind of inputs you're expecting, what kind of outputs you're expecting. And then from that, start developing the code, right? The code is everything in between. How do I get from here to here, right? And that's where the code is going to come from. Okay. And that's it. That's it. You can also do things like flowcharts, right? So first, right, you start your program. People that did programming before would know about flowcharts. So you start, you do something like get variables. So V and theta, and then some other thing, do computations, and then output data, right? And your flowchart could become more elaborate, and it got different steps in between the doing calculations. It might be first calculate time, second plot graph, right? And you can build on that. We'll go more into how we'd write flowcharts maybe a bit later, but for now, you guys are doing very simple programs, so you don't need it. Okay. Okay. So that's all I have for you guys. You can leave and I'll send you guys the assignments. All right. Good.
Sure.
If you don't have any
I don't
more
know.
questions.
Yes, sir. One question.
Yeah, okay, go.
Possible for you to send all the recordings that we've had since the class started?
Oh, so the recordings, right? Yeah. I upload them on YouTube because they're too big for Moodle, right? They're too big for Moodle. So just search Neil Chatterpaul or search ELE 1214, right? ELE 1214. And I'll try and upload all that. I only upload one so far, right? Let me put this link in the description. Yeah, shareable link. Okay, good. I only upload one so far, but I'll upload the rest soon, right? I just been busy. All right, good. All right, good. So I'll email this assignment. Good. Any other questions? No? Okay, good. So no other questions, leave. And start working on the assignments. All right. See you guys Wednesday, is it? Or Tuesday? Yeah.